Hello, and thank you for taking the time to look at our poster for the ESCoE conference on economic measurement. My name is Micael Mahony, and I'm working on ESCoE Project 2.9 using firm-level surveys to understand industrial and regional capacity, investment, productivity, and output growth. The motivation of this project is covered here in the key questions section of our poster. And each of these key questions can be answered by using the Confederation of British Industries, or CBI, their suite of business surveys. These are firm-level qualitative business surveys which constitute more than 90% of UK private sector activity. Our poster for the conference presents the key results from our paper, Output Expectations, Uncertainty and the UK Business Cycle, Evidence from the CBI's suite of business surveys. And in the interest of brevity, this poster only presents the results as they relate to the UK manufacturing sector, which are taken from the Industrial Trends Survey, or ITS for short. Results for the UK service and distributive trade sectors are, of course, discussed in detail in our paper. The key aim of this paper is to provide a time series model of actual output, expected output, and output uncertainties in the UK. Now, specifically, we use direct measures of expectations and uncertainty obtained from the ITS. And we obtained these direct measures from the survey question, excluding seasonal variations: what has been the trend over the past 3 months, and what are the expected trends for the next 3 months with regard to volume of output, i.e. production. Firms can answer this question by selecting one of up, same, or down. Figure 2a plots the corresponding quarterly output growth, which is taken from ONS official statistics and is depicted here as a grey line, alongside these survey responses. And the broad co-movements in the data are apparent. The proportion of firms reporting up, which is depicted here as the green line, rises as output growth rises and has a correlation of 0.43 between these two series, while the proportion of firms reporting down, which is depicted here as a light blue line, falls as output growth falls. And again, there's a correlation of minus 0.54 between these series. Now, these firm-level direct measures of expectations are quantified in order to derive an industry-wide measure of output expectations, uncertainty, and disagreement. Figure 3a depicts the quantitative expectation series obtained by adopting 3 alternative quantification strategies against the actual quarterly output growth, which is again depicted as the grey line. Now, the quantified expectation series, which are labelled EXP fixed and EXP rolling, are both established quantification techniques. The series labelled EXP meta, which is the red line in figure 3a, is the meta model approach to quantification, which is a novel approach which we outline in detail in our paper, and it accommodates the possibility that the relationship between growth and the reported survey responses may change over time. In fact, this EXP meta series is better able to capture the more extreme periods of output growth and contraction than the other series. It has a correlation with actual outcome of 0.65. Figure 5a depicts the quantified measures of output uncertainty and disagreement, again using the novel meta-model approach to quantification. The ex-ante consensus output uncertainty measure, which is depicted as the blue line, is obtained from an estimated Garch model applied to the expectation errors, while the green line in figure 5a is output disagreement, which is measured as the cross-section dispersion of firm responses. Now, the global financial crisis, including its aftermath, and 2019, perhaps corresponding to the UK-EU Brexit negotiations, are the most pronounced periods of high uncertainty. They are also pronounced periods of high output disagreement, although there are also high values associated in the early 2000s, at which time a global slowdown was threatening UK manufacturing. Now, the interplay between actual and expected output growth and the associated uncertainties can be captured in a relatively straightforward VAR model. And figures 6a to 9a in our paper provide a picture of the system dynamics for the manufacturing sector, setting out the response of the four variables to shocks to uncertainty, disagreement, expected output, and actual output, respectively, under this Cholesky ordering. Figures 6a and 7a show that both uncertainty shocks and disagreement shocks have a negative impact on actual and expected output. A typical uncertainty shock causes output to be 0.5% lower than it would have been in the absence of the shock, and similarly for a typical disagreement shock. An adjustment takes about 2 to 3 years. Figure 8a shows that the impact effects on output of a typical shock to expected output are about 0.5%. However, there is a relatively prolonged build-up of an effect over the subsequent 3 years, leaving output about 1.2% higher than it would have been in the absence of the shock. In each case, the actual and expected output series converge to the same levels, but this convergence is not monotonic, and it can take up to 18 months, providing little support for a full information, rational expectations interpretation of the model, in which case the output response would mirror that of the expectations response after 1 quarter. Figure 9a shows the impact effect of a typical shock to output, to actual output that is around 0.7% and also initiates adjustments over the subsequent 2 years, although the ultimate effect remains at around 0.7%. Now, while these impulse responses are useful in describing the dynamics of the estimated model, the implications for the macroeconomy is better captured in figure 10a, which plots the actual series, again the grey line, alongside the Beveridge-Nelson trend output series, the red line. The Beveridge-Nelson trends show, at each point in time, the output level that will be achieved when all current and past shocks have played out, and assuming that no further shocks occur. The trend is readily interpreted as the steady-state output level and therefore reflects the size of the shocks actually observed in the data, as well as the infinite horizon effects captured by the impulse responses. Now in figure 10a, output falls some 2.5% below trend during the global financial crisis, but broadly tracks the trend from 2012-2013 onwards. Now, figure 10a also plots the Beveridge-Nelson trend that would have been observed if there had been no shocks to uncertainty or disagreement after 2007 quarter 4. This is depicted as the sand-coloured line in figure 10a. This trend lies above the original Beveridge-Nelson trend throughout the period, showing that the shocks to uncertainty and disagreement caused trend output to be some 2.5 to 4.5% lower than it would have been in the absence of shocks through 2008 to 2012, and some 1 to 2% lower at the end of the sample. So the main conclusions of this paper are: accounting for structural change yields improved direct quantitative measures of output expectations and uncertainty over existing strategies. This is our meta-modeling approach. Output uncertainty does provide a negative source of shocks to output incomes. And while usually small, they did cause a relatively large permanent drop in output in the years following the global financial crisis, in the years following the sovereign debt crisis, and during the period of UK discussions on leaving the EU. Again, I would like to thank you for taking the time to examine our poster.